So you found a new dataset that you're excited to explore, or maybe you just want to get familiar with using Python for data analysis. Well, in this video, I'll show you some of the essential skills that you'll need to know in order to perform data analysis with Python. We will apply the data analysis directly to a EA Sports FC 25 dataset. Hello, my name is Thomas from Pyginners. If you haven't installed Python on your computer yet, don't worry. I have a video on how to set up Python and you can find the link to it in the descriptions of the video. Also, the dataset and the Jupyter notebook we'll be using are available in the notes below, so you can follow along and practice on your own. So with that, let's get started. So here we are in a Jupyter notebook, which is just an environment to run Python code. And first we'll have to import certain libraries in order to perform our data analysis. I'll start by importing Pandas, which is a useful library for data analysis. I'll type in import pandas spd. Also, we will need NumPy snp, and to do some visualization with data, I will import two other libraries, Matplotlib and Seaborn. lib.pyplot spt and import Seaborn, which is a very powerful library for data visualization. Import Seaborn as SNS. And I'll run this cell either with the Shift and Enter, or you can also click on this icon here. If you haven't installed a library yet, you must install it first, and you can do so if you hit pip install and the name of the library that you want to install. For example, pip install pandas, and execute the cell. And for me it says requirement already satisfied because I had installed it previously. So you have to make sure that all libraries you want to use are installed before you use them. All right, I'll delete this cell again. And let's start by reading in our data set. You can assign a name to it. I'll type df for data frame equaling pandas.read CSV. Also, if you hit the tab on your keyboard, you have an auto-completion for various options, and I'll choose pandas read CSV and quotation and the name of your file. If I hit tab again, I'll see my file name. Make sure to end it with quotation mark again, and encoding is another parameter that I choose, and I set it to UTF-8. Okay, now let's execute this cell. Oh, there's an error. Now, if I type in df.head, we see the data frame that has been imported successfully. So we have a couple of columns here. There's the rank of the player and the player name, nationality, position for the player, the club he's playing for. And then there are a couple of skills that we can see. They're not all of them, but here we have the overall rating, pace, shooting, passing, dribbling, defensive skills, physicality, goalkeeping skills, and the total number of all different attributes for a player. All right, let's move on to data understanding. If you type in the name of your data frame .info, you will see that there are 100 entries for each row, and luckily there aren't any missing values because we have null for every attribute. And another important thing to know is the type of each column. We have integers, for example, for the rank, and the player name, nationality, and position are all, plus the club, are all objects, strings also called. And the rest are numbers again, so they are integers. So with df.head, we were able to display the top 5 rows of our data set. But we can also have a look at the tail of our data, and let's do that. If I type in a number here, I will get exactly this amount of rows. So let's say 7, for example. And now we see the last 7 entries of our data. Players ranking from 94 to 100. Another interesting function is df.sample, which returns a sample, and we can again enter a number here. If I type in 3, 3 randomly chosen rows are shown for us. For example, here Eder Militao, William Saliba, and Gabriel. Coincidence, all are central back defenders. If I execute the cell again, we will have some other players. Rodri this time, Saliba again, and David Alaba now. Okay, let's move on with some exploratory data analysis. Let's say we want to display a count plot of the overall strength of the players to see how our data is distributed. I will use the Seaborn library now and type in sns.countplot. Parameter data will be our df. The x-axis will be df.overall. For a coloring palette, I'll choose winter. There are several options here for different color palettes, and hue parameter is df over. And we can set a title to our chart. I'll call it distribution of overall ratings. And by hitting plt.show, we should now see our desired chart. Perfect. We now see how the overall strength is distributed, and for example, with overall strength of 91, there are 3 players. We can also check this by hitting df.head, and we see that Mbappé Rotary and Holland have 91. So that makes total sense. And most players can be found at overall level 85, as we can see. So something else that I'm interested in is a correlation matrix. So which features are correlated to each other. And I will type in core matrix and choose some parameters that I'm interested in. I want to know about pace, shooting, pass, dribble skills, defensive, and let's also pick physicality. All right, so this is a new data frame with only a selection of attributes. And if we type in core, the correlation matrix will be calculated for this data frame. However, we also have to type in sns.heatmap because we want to display our matrix as a heat map. So as the first parameter, I'll type in data equals core matrix that we had defined before. And the annotation should be true so that we see the values in each field. Again, I'll set a title. And I'll pick attribute correlation matrix. And again, plt.show. Okay, let's see what we got here. The lower the correlation, the darker the color. So, for example, we have a very low correlation for pace and defensive skills. So I assume that many defensive players are not the fastest. Also, a great defensive skill usually is not correlated with good shooting skills. However, on the other hand, we have, for example, a very high correlation from dribbling to passing. This is typical for offensive players that are good at both dribbling and passing. Or let's pick another example, shooting and dribbling. Also, many offensive football players are good at both shooting and dribbling, so it makes absolutely sense that we have a high correlation here. The next thing I'd like to do is to do a top player analysis to find out on which position are the strongest players. So let's create a new data frame that we call position stats, equaling, and then we have to use the group by function, ef.groupby. Interested in the position. I want to find out my following attributes and the mean value for these attributes for the position of the players. So we'll pass in a list of the features we're interested in. Overall strength. I'll copy paste the same attributes from here now, starting with pace, going to physicality. And after this list, I have to enter the function that I want to apply, and I'm interested in the mean of all these values. So I'll type in mean, followed by reset index to have a nice data frame again. And I'll also want to sort the values, and I can specify the value which the data frame is sorted by, overall, and ascending is false. All right, let's execute this. Okay, we don't have an error. And now we want to have a look at our grouped data. Great. We can see now that all entries are sorted by the overall strength. And as we can see, left wing, we have the strongest players for left wing, followed by goalkeeper and striker. And the smallest average goes to right midfielders, and left midfielders are just slightly above them. All right, and there are some other stats we can also look at. For example, we can see that the left wing back have the highest pace on average, and not surprisingly, goalkeepers are not that great when it comes to pace. And let's have a look at physicality. I expect it to be higher for defenders than for offensive players. For instance, central back have 83 on average, and strikers, left wing backs are even stronger, and strikers, yeah, they're also quite good, 81, but central midfielders are okay. Left midfielders are pretty low. Also goalkeepers, 55. Okay, another question that I'm interested in to find out with this data is which country has most of the top players. So I'll go on and define top countries equals df and the parameter, which is nationality, and then we'll use the value counts method, which counts how many entries there are for each unique value that we define, so for the nationality in this case. And I'll only want to see the top 10 nations. So if we just execute this, we will see that France and Germany have most of the players in our dataset with 11, followed by Portugal, England, Brazil with 10. So I will create a nice chart with this data again. I'll type in sns.barplot this time. For the x-axis, I'll choose the values from our top countries. And for the y-axis, I'll type in top countries, the index, which is the country. For the palette this time, I'll choose magma. And for the hue, top countries index again. Title this time is top 10 countries by number of players, and plt.show. We see that top 2 countries, France and Germany, at the top, and Belgium at the bottom, followed by Switzerland with 4 players, and Argentina, Italy with 6 players. So let's raise another question about our data. Let's say I want to find out how the shooting and the passing skills look like for just 2 different positions. I'll type df filtered equals df, and I'll use the query method here, and I want to only find players which have position in either striker or central midfielder. Have to end it with a quotation mark again. Let's run this, and if we take a look at df filtered, we see that it worked. We only have strikers and central midfielders now. And let's say we want to display shooting and passing skills on a scatter plot. We can do so now by first setting a plot size that is big enough. I'll type plt.figure, and in the brackets fig size is, let's try it with 8 and 8. And we will use the Seaborn scatter plot. Our data is df filtered. On the x-axis, we want to see the shooting parameter. And on the y-axis, let's go for passing. I want my dots to be colored by position, which is really helpful to distinguish the 2 different positions. And another column that I want to include is the overall strength of the player, and it will be displayed by the size of each dot. So we choose size equals overall. Okay, and let's choose a title. I'll pick shooting versus passing for strikers and central midfielders. And the X label is shooting and the Y label is passing. All right, let's have a look how this looks like. Nice. We see now that the shooting strength is at the X-axis and passing on the Y label, and that the central midfielders usually have the better passing skills, and the strikers, which are the blue dots, are more on the right side of our chart, which indicates good shooting skills. Here we have two players that have exactly the same skill number for both skills, as it seems. However, we see that the central midfielder has a better overall skill because its dot is bigger. Also, we can see that the overall strong players usually are more to the upper right corner, which makes perfectly sense because the overall strength correlates with the passing and shooting skills. So this was my first exploratory data analysis for a dataset. Please leave me a like if you found this helpful, and also please leave any questions down in the comments. Make sure to subscribe to my channel to not miss any of my future videos, and yeah, just let me know how you like this kind of content so that I know if I should produce more of such exploratory data analysis. Have a wonderful day and see you next time. Bye bye.